Good morning, everyone. This is Jim Chastain with EasyPower. As we're getting started here, even though this is a listen-only audio feed, I want to encourage you, if you're an EasyPower tool owner or anyone having problems with ArtFlash issues, by all means, you're welcome to send questions and emails. I may not be able to get to them on this particular session, but we can respond if you send an email to me or tech support, and we can deal with it as a follow-up. Welcome, everyone. So what I wanted to do today was touch on a couple things briefly. Specifically, when we get to the demonstrations, it'll be on sequence of events and maintenance mode. And before we get there, I wanted to touch on we have a lot of resources available to folks that own EasyPower tools. And I wanted to make sure that everyone's aware of not only how to access these, but how available and how easy it is to deal with problems pretty much real time. It's not like you have to struggle with something if you run into a situation and you may not have resources at hand, either at your local shop or facility. And all you need is a little bit of guidance to get over a hump. So let me kind of offer the following list. So for beginners, the three phases of learning the tools is, first of all, to start with the mechanics. Just how do I open files, save files, use certain libraries, use certain menus. And these are basically the mechanics that we have a number of tutorials online. If for some reason it's not jumping out at you what you're trying to do, by all means send me an email and we can kind of get you off and running fairly quickly. We have a series of online webinars weekly, and some may be more advanced, some may be just what you need, but I want to encourage you not to just sit there and struggle with something if it's not making sense. Secondarily, if you have some experience with the tools, or you're beyond the point of just learning how to use the tools, there can be very frequently that you'll just have a one-off question that can be answered relatively succinctly via email, or you just want to ask somebody a question real quickly. Well, frankly, that's the focus mission of tech support. And for any tool owners that have current maintenance, the purpose of their availability, virtually 8 to 5 Pacific time, and often even earlier and later than that. And so I encourage you to send an email or call EasyPower at 503-655-5059 and ask for tech support, and you will get immediate responses. We try to turn around even emails within 4 to 6 hours. Likewise, if you're having an issue with a problem with a specific file and you can't seem to get beyond something that's kind of befuddling you, it doesn't seem all that complex, but for some reason the tool isn't responding the way you think it should, again, feel free to send me a copy of the file, and frequently it's just a real quick guidance or a pointer to the help instructions in the manual, and you can get off and running. So don't hesitate. Again, don't struggle with something like that if you're trying to get a project done. Likewise, we have dozens of in-depth tutorials online, and I encourage you, as you learn more about the tools and you try to understand more about what your particular needs are, I encourage you to go in as frequently as possible and view the pre-recorded sessions, and even those sessions may give you reasons to ask additional questions. And again, we have weekly webinars that get into various technical depths of different subjects, and these are posted on the website. You're welcome to attend all those free of charge. Likewise, as you've been a tool user for a few months or even a few years, you may find it very informative to expand your capabilities by attending a regional training session, which we've expanded now from quarterly to 5 or 6 times a year, and rotate the location around the country. We're just coming up on, we just finished one in the southeast. We're coming up on one in Toronto here mid-year, and then later in the year again in Portland. So those can be an excellent way to, because they're all hands-on training, to get leaps and bounds ahead in your skill set on being able to utilize the EasyPower tools. And then I would like to suggest that there are occasions where you need expert help. And I'd like to offer access to EasyPower Engineering Services. The mission of the group is to facilitate EasyPower tool owners' successful applications of the tools. This applies to facility owners, it applies to consultants, it applies to anyone that has the tools and feels the need for, if you will, a deep technical expert in a subject that maybe you don't have enough training in the shop. You may have someone that usually deals with, say, device coordination. They're on vacation as you've got a project in that needs to have that incorporated into the project. Be more than happy to provide quotes on providing that type of support, either counseling, training, or doing the study by sending us the files. We can give you a quote on what the cost would be. It's literally a time and materials, and we can help you learn to utilize the tools, and you can see how an expert handles a particular study or particular problem by doing so. So very frequently, it's an easy way to help expand your market or your capabilities before you have to go out and invest in that type of skill set within the organization and test out to see what your local market really needs. And then finally, customized training can either be on-site or online, and this very much can be included as part of a specific project where, now that you see how an expert handles a particular situation, you can better ascertain whether that's within your wheelhouse or if it's something you want to be able to bring your team up to speed on. In any case, there are a host of alternatives to anyone, any tool user that needs a bit of a helping hand. So frankly, that's a word from our sponsor. I appreciate kind of the opportunity to do that. What I want to do today is jump in very quickly to two key topics of that kind of cover both issues that beginners have and tool veterans. And I guess with that, let's kind of go for talking as I go. So there's two areas I'm going to talk about, and both of these go to how to deal with mitigation, energy mitigation, once you've developed your tool, your model, and if for whatever reason you're having issues bringing down energies or dealing with a particular bus that's not doing what you think it ought to do. Back to the question or the issue about getting help, I like to point out usually every time I do a demo of the tools that we have tutorials that are installed with the tool installation, and these include samples that you can walk through and see how that specific topic is handled. And so as you go through this particular list, there are basic examples, and in the sample folder, preset, pre-drawn OneLine diagrams to allow you to follow the tutorial and walk through the steps it requires to do that particular analysis. Likewise, there's a manual online that's included with the tool, and it's available both online and offline, but it gives you a searchable 900-page manual with a lot of depth in terms of not only how the tool is manipulating data behind the scenes, but the justifications for why it's asking and for certain data and why it's important in the particular step that you're operating on. All right, so what I want to do, first of all, is actually kind of utilize one of these examples that we're talking about. And here's a one-line diagram. It's kind of typical of one that we will get from a new user. And very often people will draw a one-line diagram similar to this and then try to go into short circuit study, short circuit focus. And so what the tool is allowing me to do is move from the database editor into short circuit without an error message. And what that tells us is that the tool seems to think that there's enough data to do analysis. But as I fault the buses, you can see that we have a number of reports that come up, one of which we want to be the arc flash hazard report. And by looking at that, if we don't see incident energy on the one-line diagram, frankly, the first place to go is the arc flash hazard report, because that tells you specifically the data that's being used on each bus is for the calculations, incident energy. So you can see here very quickly that the tool is not being, doesn't have access to the details on a protective device that's upstream. So if we go back to the database editor and we look at what's going on here, we've got obviously 480 volts. We got a breaker that's closed. Looks like we have a fuse switch that's open. So starters, we need to close that. And do arc flash, fault the buses, incident energy calculation. And then as we look at the one-line or the arc flash hazard report, you can see that we don't have valid protective devices. Okay, word of advice. Again, this is more the beginner's corner. As we're looking at a one-line diagram, the last thing I would recommend is doing something even this complex before you start verifying you have a handle on how to do the analysis. So what I would suggest is going in, highlighting, and disabling. If we're in the database editor, we have the ability to deactivate certain parts of the one line to limit our focus. And so as we deactivate that, we can come down now and look at specifically what's going on. And more often than not, if we are not seeing protective devices show up on our arc flash spreadsheet, most of the time it's because we haven't fully characterized the requirements or the parameters required to describe this particular protective device. So even if you don't have a fuse in the main line to kind of troubleshoot what's going on, very often I'll put a fuse in there, and in this particular case you can see we have a fuse, and I just haven't been able to go in and finally characterize the trip characteristics of this curve. I didn't set up the size, which is necessary, and by so doing, if I'd like to see this number change, by hitting calculate, that means the tool has gone out and found this particular data sheet, and now it's going to be able to calculate equipment duty against this particular test parameter that the manufacturer guarantees. So just with that one change, let's go back and see that we've got, we may have created a problem for ourselves by doing my deactivation, but that is actually an improvement over where we were. So again, what this shows is that I've deactivated this particular bus. So by activating that and still have the loads deactivated, we should be able to go back online. All right, so now we're faulting the bus, and now we're seeing results, calculations, and likewise, we're seeing some elements that still aren't connected or don't see a trip device. So far and away, this is the most frequently seen beginner's mistake, and that is you haven't fully characterized a protective trip device. I think that's probably enough said, but the bottom line is understanding that what is going on from this particular spreadsheet is this describing the bus that's being faulted, the protective device, or the voltage on the bus, the upstream trip device, and then the equipment type that's being characterized, which gives us the arc gap. With all these elements completed, we can see what's utilized in the IEEE equations to calculate arc current and incident energy. All right, so that's the beginner section. Let's jump into a little bit more advanced question on sequence of events. Okay, same kind of a situation. Essentially, a first-time user OneLine, nothing necessarily at odds with what's going on. As we enter short circuit, we don't get an error report, which is a good sign. We go ahead and fault the buses, and we see that we have a lot of relatively high incident energy. And as we look at the arc flash spreadsheet, we can see in some cases we don't have a valid trip device, but this is on our high voltage. Interestingly enough, here on bus 4, which is a low voltage 240 bus, we don't see that we have a valid trip device. This brings up another question that sometimes looms, and that is, I want to go in and look at bus 4. So I'm going to look at buses, pick up bus 4. So this is showing me a situation where we have utility service, bus 4. In fact, the whole system looks like it's 240 volts. So since there's no protected device in line here, we might not necessarily see or have the ability to calculate incident energy here. But the question is, why are we seeing such high incident energy in these other places? So there's a couple places to look. First of all, go and look at your short circuit options, arc flash hazard controls. So let me again touch on that. Under short circuit options, arc flash hazard tab, this is what controls how the IEEE 1584 model is applied. First of all, we want to consider or look at what we're doing with the main breaker on any particular bus. So as we apply this, what we're suggesting is, if this bus is the one being faulted, we may or may not want to include the upstream breaker for this bus because it may not afford us protection against the high side or the upstream conductors on this particular panel. To do that, or to deal with that, under our options, we would either include or exclude the main on that particular panel. On this particular case, he doesn't have a breaker, an upstream breaker, so I'm going to go ahead and include that right now for part of my analysis. Second thing to look at is how the tool handles the different parts of the voltage spectrum. And I caution you to not immediately jump to this as a fix to whatever you're doing in low voltage. There are apps notes out, and there's a little bit of confusion between NFPA 70E and IEEE on how to handle low voltage buses. In reality, empirical data shows that arcs that are initiated in 240 volts or less very frequently self-extinguish in less than 200 or 300 milliseconds. So there's a good case to artificially limit the amount of time we allow our protective device to be considered as far as the calculation. So a case in point will be in these particular examples. Here we've got an arc time of 2 seconds. Here's an arc time of 7 seconds. These are all artificially high, but rather than go to the limit immediately, I would recommend looking at the trip device and make sure it's properly sized before we do anything with the trip time, the max time. All right. All right, and so rather than go into the details of that, it's kind of brings me to the point of talking about sequence of events. With the ability to use coordination, the coordination module, we enter coordination, we can pick a specific bus and fault it. Looking at current, we can also look at the sequence of events. By clicking this little icon here on the lower row, it will give us the ability to go up and look at the sequence of events. And if we go into the Protect Your Device Coordination, request a sequence of events report, and apply it, fault the bus again, we will see in our stack of windows a sequence of events reports. And so now for any particular bus, this will show us which breakers are tripping. And you can see by this report, virtually the only things that are tripping are the upstream fuses. So that would tell us that we don't have any inline breakers in any of the panels, either main or intermediate in place. So again, thing we would go back and do is look at what's been characterized in this particular panel. In this case, we don't have any protective devices, and secondarily, even if we did, the constraint that we looked at initially, whether or not we're including main or excluding main, would be part of the discussion. Okay, so let's kind of go on to one more example. Again, if you want more detail on this, by all means send me an email and we can get into specifics of any particular problem you're having. All right, so here's an example of a fairly complex system, and it's complex in that it has multiple voltage sources, tie buses, and then switchover. The question is, for any particular bus fault, what's actually going to protect it? We go into coordination, select the bus, fault it, look at the branch current, and then look at sequence of events. That tells us in order upstream devices that'll trip. So here we see this breaker will trip in 50 milliseconds. This breaker trips in 190 milliseconds. This relay is going to trip in 250 56 milliseconds. Here's another one that's tripping in 23 milliseconds. And so it would appear that at first blush, these are miscoordinated. On the other hand, if I go in and I produce my sequence of events report, what this allows me to do, rather than go in and make adjustments on a particular device that may not be actually controlling the trip settings, so by faulting this particular bus, I can see that in order, there's fault current going through all of these. Well, it's not the equipment duty. Sequence of events. Sorry about that. As we look at a specific faulted bus, you can see that there's current actually flowing through several number of breakers that we may or may not consider in series with wherever that fault is. You can see that actually relay 3 is being affected through a couple different routes, and therefore just adjusting one connection through that route may not really reduce the incident energy or the trip settings that I'm trying to deal with. So even before I go into coordination, I think it's important to look at what your sequence of events report is telling you and making sure that you're making adjustments on the limiting factor rather than the one most upstream. In this particular case, you can see that there are at least one, it looks like one relay is actually out of whack compared to the trip settings of the switchgear A, and it's potentially seeing current from two different sources. As I go back and look at my one-line diagram, I can see that might be the case if we're, especially if we have some of these tie breakers closed and multiple sources of voltage on at the same time. All right, then finally, so again, I recommend using sequence of events anytime I start doing device coordination, because it'll give you a real awareness, especially in complex systems, of multiple current paths that may not be obvious as you're doing the one line. Okay, then the last thing I wanted to talk about was my maintenance mode. Again, once we have the one-line diagram completed, very often more modern components will have the ability to invoke maintenance mode. And as we go into the phase trip settings, this is called or referred to as reduced energy let-through or maintenance mode, based upon whichever manufacturer you're utilizing. But having that configured as you set the part component up in the database editor gives you ability, while you're in short circuit analysis, to go in and invoke maintenance mode. And as you turn on, and you'll see all the breakers that have that available, and this gives you the ability to now predict or come up with a procedure to be able to work on this particular bus by invoking maintenance mode as part of the procedure. So what we're seeing here is if we engage maintenance mode on all these devices, that we actually bring this bus to a point where it can be worked on in a hot condition and have relatively safe conditions for the technician working on it. This is valuable both in terms of, both in terms of mitigating incident energy, but also in coordinating and looking at alternative ways of bringing down or making sure you have coordinated breakers in the circuit. As we go into coordination mode, we can go ahead and plot all three of these devices. We can fault the buses, look at the incident energy, and now we can see that we have several devices that have set points that allow a fair amount of energy to come through normally. If we go in and invoke maintenance mode and turn it on, we can turn it on individually or for the whole system, and we can see now what's happened to specific devices as far as their protective capabilities, their short-term pickup. Again, that's built into the tool. It's built into the just the short circuit options, and we're looking at it here with the coordinated the coordination module. All right, so the name of this particular function is called maintenance mode. It's accessed by right-clicking either in short circuit focus or coordination focus, right-clicking, selecting maintenance mode on or off, and it deals with the whole system. We can pick up an individual breaker and invoke maintenance mode there, so let's go ahead and fault the buses. Invoke maintenance mode for this particular breaker, and now we can see that it has the same effect as doing all three, or close to the same effect as doing all three breakers. So again, the two features we're talking about are fairly, I think, extremely valuable when you get down to the nitty-gritty of a specific application. And maintenance mode is a feature of more modern breakers that have the ability to kind of do a setting after the breaker's been activated, and oftentimes it's called, as we go back and look at this setup on these particular devices, it's called maintenance mode or reduce energy let through, and it's part of the setup of that device when you're drawing the one-line diagram. Then the other issue we looked at, or the other tool we looked at, was sequence of events report, and that's part of the coordination module, and very often it's a good place to start when you're looking at device coordination. So right now I'm going to check to see if we have any questions, and I appreciate everyone for attending today. I encourage you to go to the website for additional in-depth tutorials. Contact tech support at easypower.com or send me an email with your files if you got specific questions. Thank you.